going to start by just sketching a cube out. Now, which cubes only touch four other cubes? If I start drawing some lines in, then actually it becomes apparent that it's these sort of cubes that touch four because it's got one to its right, it's got one to its left, it's got one below it, and it's got one behind it. So actually it's all the ones along the edges. This problem then becomes a case of working out how many edges a cube has. Well, we've got four at the front in this square here, and then we've got four at the back with this square here, and then we've got another two here and another two here. So 12 edges in total. And the reason that's useful is because I've got 168 of these cubes, but they're going to be split up along these 12 edges. So I need to do 12s into 168. So 1, 4. What that means is that there's going to be 14 cubes along each of these edges, except remember, we're not going to be including the corners. So 14 along this kind of pattern, 14 along another edge and another edge, in fact, all 12 edges. But that means each edge in total is going to be 16. And we've worked out the length of our one side of our cube. 16 cubes. So overall, the volume, or how many small cubes, the same thing in this case, is going to be 16 times 16 times 16. And there's a few ways you could do this. You could do 16 times 16, which is 256, and then actually, yeah, I quite like this approach. It's good if you know a few square numbers like that, so 256, and then to times by 16, of course I could do a column multiplication, or I could just double it a few times. So if I want to times it by 2, the 256, it will become 512, times by 4, double this one again to 1024, times by 8, then double again to 2048, which means if I want to times 256 by 16, I double it 4 times, and I'm going to get 4096, and that's going to be our answer. One of the method, and this is the method I actually used, was to write it as powers of 2. So 2 to the power of 4 cubed, in fact. That's what this is, which means it's 2 to the power of 12. Now 2 to the power of 10 is a number worth knowing. It's 1024. It's a really good one because it's quite close to 1000 and it has lots of applications in, with computer science, with kilobytes and so on. So then we can just double it twice to give 4096 that way. So it's just a little suggestion. Look, I'm sure you got a way to find it once you get to 16 times 16 times 16. I'm just showing two possible routes that don't involve column multiplication. Good question. Keep going.